And we're live. Yes, excellent. And actually, I think 3 people. Yes, there's 3 people so far. There might be more. We'll see what happens. Anyway, here we are, back in class. For the record, you've seen me teach virtual. While you guys were virtual, you saw me teaching from my home, and you saw me teaching from an empty classroom. Personally, I prefer teaching from home, not because of the general concept of like, I want to be home, but from the general concept of I can teach better from home than I can here, simply because of my computer and the setup that I have. Otherwise, I have to use this thing here because I don't have the proper setup on this computer. It's such a mess. Anyway. No, I'm saying I should probably be home. Well, let me ask you the question. So last 2 weeks, you saw me teach virtual lessons from my classroom, and you saw me teach a virtual lesson from my own house. Which videos presented better? Yeah. I know. But the thing is, people teaching from home, like other teachers teaching from home, were they just like teaching like literally from like a Google Meet or a laptop, and it's literally you face to face with them? Yeah. Whereas with me, you could see my face, you could see what I'm writing, I could transition to websites, I could transition to widescreen. No, I know. And you want to know how much training we were given on it? You want to know how much training we were given on virtual teaching? Big old 0, big old goose egg. So, as I mentioned, I will be assigning a major assessment this week in regards to the chapter we've been covering. My goal for today is to do a deep dive review on a couple of problems that I have. And when I say a deep dive review, I mean, we're going to spend a lot of time with just a few problems. It's going to be amazing. But first, I wanted to talk about Cali scores, because the math involved with this is phenomenal. A Cali score, as you can see at the top, COVID-19 activity level. The Cali, the C-A-L-I, the I stands for index. But you can see right here, as of the most recent report, which was released last week, you can see the entire state of New Jersey is listed as high, which is 3 out of 4 in terms of a Cali score, 3 out of 4. If the county's Cali score reaches a 4 on average, we have to go fully virtual. We have to. We don't have a choice. Yes, meaning you guys, well, I don't know what I would do, but you guys would be virtually learning as long as we are in this red category. Now you can see right here, we shut down mid-March, right? Shortly thereafter, we were in the red for a while. And then we went orange, and they decided, well, we're going to stay virtual. We're going to stay virtual. Here's the end of the school year. And then during the summer, things got better. We went back down to level 1. And then level 2, level 1, and then level 2, and then November 14th, we move back into level 3. Level 4, we go virtual. Yeah, for as long as we are in that state of being red. Now, the thing is, how does one calculate a Cali score? It's based on 3 categories. Each of those 3 categories is given a score of 1, 2, 3, or 4. And they average those scores together in order to determine the county Cali score. As you can see, all of New Jersey, every single county individually has a Cali score of 3. Every single one. It's a county by county thing. Now, we are technically Central East for the sake of argument. That's us right here, Central East. 3 categories. The first category is cases per 100,000 people. In that, we are a 4. We are a county, the state. We just hit 5,000, 6,000 cases a day. Our Cali score, our ranking for that case rate is definitely in the red that you can see right there. That's a 4. Let me write that right here. This be a 4. Then the percent CLI. Not many people know about this. Percent CLI. CLI stands for COVID-like illness. Basically, you go to the doctor, say, hey, doc, I'm not feeling too well. I think I may need to get a COVID test. Okay, well, let me check you over. Okay, I don't believe you have COVID. Maybe we'll get a test and you'll show up negative. but you are definitely experiencing COVID-like symptoms. That's the doctor's opinion. The doctor then reports that information to the proper authorities, and you are added to that percent rate of COVID-like illness, which currently we're at about 7%, which, according to the Cali Index, makes that a 3. In order to make that a 4, you would have to have a percentage over 13%. Now, this is the last week's report, percent positivity. But 20 people go in to take a test. 2 of them end up being positive. That's a 10% rate, 2 out of 20. That's basically what percent positivity means. Now, according to this, it was 9.8%, which is good enough for a 2. But this upcoming report, that's going to be over 10% because the entire state is at 11%. So that's going to be a 3. Now, according to this report, this averages out to a 3, which is our Cali score. The next time this comes out, I guarantee you this number, the next time it comes out, this number will be a 3, which puts us at 3.33, which will round down, so we will still be at a 3. Question? Yes. Yep. I don't know. Here's the thing. When you're orange, the school district has the option to go fully virtual, which is why some school districts in the state have done that. But our school district or the county school district, whatever, made the decision to go to school. Now, whether or not it spreads, now keep in mind, not everybody in the general public is continually masking. Not everyone in the general public is continually using these things. Not everyone in the general public is continually disinfecting. Some people are going to have Thanksgiving with 30 people unmasked in a tiny room.
That was a bit.
Nah, I'm sorry. I shut down my Thanksgiving. I didn't see my own parents on Thanksgiving. I'm just saying. Because I'm trying. Anyway, keep in mind, do you guys know why you quarantined for 2 weeks? Why did you all quarantine for 2 weeks? Does no one know why? One teacher had it, and it was exposed to an entire department. And that department had to quarantine for 2 weeks. Yeah, that's literally what happened. After school, you know how you guys all leave at 11:40? After school, teachers 3 days a week have what we call PLCs. PLCs, Professional Learning Communities. Hey, great idea. Let's get all these adults together in a room where they have to be within a certain distance of each other for an hour and a half while we're working on, stuff, when we could easily have a Google Meet over the computer. Yeah, just saying. They changed their idea. That's what happened. We had the meetings. One department got exposed. They had to quarantine for 2 weeks once they found out one person had tested positive.
Are you guys still having meetings?
Yesterday, we had a meeting in the library again. Today, they changed it. Because a bunch of teachers complained. Now, here's the thing. How does that round up to a 4? What does it have to be for it to round up to a 4? It has to be 3.5. We're that close. Once it gets to a 4, we got to shut down. But here's the thing. In order for this to be, now mind you, in order for it to round up to a 4, 2 of these have to be 4s. 2 of them. 2 of them. This can't be a 4 until it gets to over 13%. This can't be a 4 until it gets over 20%. This number is artificially shrunk. Because there are too many people going in panicking. Oh my God, I have COVID. You're fine. Like, you're not even experiencing symptoms. Yeah, but I got to go get tested. And then they end up being negative, and then they end up going and get tested again the following week because, again, they panic. Now, is it good to get tested maybe like once, oh man, I might have been exposed. Is it good to get tested? Yes. Yes, it is. It's a good idea to get tested. Is it a good idea to get tested every single week because you panic? Probably not. But those people who get tested every week, that's artificially deflating this number. Anyway, that's where we're at. Woo! Have you seen the COVID chart for New Jersey? Number of cases? Check this out. Math. Minute of math. You'll see that? Those are the cases for New Jersey. That's where we're at right now. Oh, that's April, but this is yeah. Anyway, I love this stuff. Statistical analysis of COVID-related things. It's amazing to chart this over the course of time. Anyway, I digress.
So pretty much it's the same as the numbers tell us.
Not necessarily. Like I said, because we have a Cali score of 3, we have the option to go fully virtual. The option. And it's strongly suggested that we take these precautions, as you see in front of you right now. For example, when we had a Cali score of 2, we didn't have the barriers. Once the Cali score got up to 3, oh crap, we got to have these barriers. You know what I'm saying? That's literally what happened. So that's where we're at. And once we get to a 4, we got to shut down. But I don't think we're going to get to a 4 anytime soon, unless somebody drastically changes their mind or they stop manipulating the data. Anyway, here's what I'm going to need from you in order to get this thing started. I'm going to need those notebooks out and open. I'm so excited for the problem that I have for you today. This is going to be an amazing problem. That little thing. There it is. Yes. I want to position the problem up here. I want to do a reveal. So I'm going to mute that. There we go. And I'm going to put this up here. Zoom out a little, zoom out a little. Boom. As I said, I do have a major for you this week, and it will be assigned via Google Classroom. I want to focus all of our attention today on just a few problems. But these few problems are going to have a lot of information involved with them. I know exactly what happens when a high school student is faced with a word problem. I know exactly what happens. If you had to make a list of your top 5 or even top 3 most hated things about math, you would put on near the top of that list possibly word problems. Most of you would. You look at a word problem, you might immediately, oh gosh, a word problem. Okay, fine. And then you skim the numbers and you hope for the best. That is typically how a high school student handles a word problem. You skim the numbers and hope for the best. Maybe if I stare at it long enough, something will happen. Ugh. I want to deep dive a word problem today. It's the problem I got for you right here. Now, I'm going to spend a lot of time on this particular problem. You do not have to write down this problem, but I am going to expect you to write down certain things into your notebooks. I will show you. I'm going to write my own notes out, and that's what you are going to write down as well. But let's see what this problem has in store for us. This problem, a tool shop is hired to make a metal mold in which plastic is injected to make a solid block. See the diagram below. Now you can see in this diagram below, I'll move this up just a tiny bit more. There we go. You can see in this diagram below, they have an outer shell, which is that metal mold, and they have an inner space, which is that dotted line. That inner space is where the plastic is going to go when it is injected into the metal mold, and it will eventually solidify, and they will open up that metal mold, and you will have a plastic block. Okay. The finished plastic block should have, oh gosh, words and numbers. The finished plastic block should have a length that is 8 inches longer than the height. It should also have a width that is 2 inches shorter than the height. Each block require, oh my gosh, this is literally what you guys do. I hear it in your heads. Every time you come face to face with a word problem, I see it on your faces. When you read through something like this and you panic and you skip it. Or maybe it's the last problem that you got to do. Maybe you'll leave it blank. Maybe you'll try your best. You can do these problems. You have to decipher what it's trying to tell you. You have to decipher what it's trying to tell you. That's the whole point of word problems. Each plastic block requires 96 cubic inches of plastic. If the sides of the mold are, oh my gosh. Okay, hold on. Let's stop right there. I'm going to break this problem apart for you. First, let's break it up into two separate things. There is the plastic area that is on the inside of this mold, the plastic portion. The portion that is going to be filled with plastic inside of this mold. Let's focus on that first. Oh no, I almost tripped and died. At that point, several of you giggled. And then I would say, oh my gosh, I could have died and you giggled at me? Let's see what we got here.
I don't know what I'll do if you die.
You don't? I think it'll be, I think you'll move on. Yeah. Let's call this polynomial word problems. That wasn't impressive. I banked it off the wall. Let's see. Polynomial word problems. Here, I'll show you something more impressive. Ready? You ready? It's going to go straight in the trash. You ready? No, this is going to go straight in the trash. Guaranteed. You ready? Nailed it. All right. That was pretty impressive, though, right? Just saying. Let's talk about the plastic block.
You have children.
2. Why?
This sounds like something like a dad would do.
I've been doing that way before I had kids.
Maybe you've been a dad.
I've pretty much been like in dad mode since I was like 14.
So
Anyway.
you've been a dad since then.
No. I'm trying to manipulate things. Anyway, back to this. So, first, hopefully you all know how to draw a 3-dimensional rectangular prism. Pretty much in geometry, this is what you did to kill time, wasn't it? Draw 3-dimensional shapes. But now, I go back to the problem. I'm going to read some things from the problem. A tool shop is hired to make a metal mold. Now, this is the plastic block. Notice I am labeling it as the plastic block. Oh, no, he's stepping on my cord. There he is. Sorry. This is the plastic block. I'll save the metal mold for later because the information that they gave me in the problem was specific to the plastic block that they described. It says that the hire to make a metal mold in which a plastic is injected to make that solid block. Okay. The finished plastic block, which is this thing, the finished plastic block should have a length that is 8 inches longer than the height. Notice what I just labeled right here. Notice what I labeled, and now I'm going to read that statement again. The finished plastic block should have a length that is 8 inches longer than the height. Well, I don't know what the height is, so I'm going to label it as x, which means that the length should be 8 inches longer, x plus 8. The following statement, it should also have a width that is 2 inches shorter than the height. 2 inches shorter than the height. These are the dimensions of the finished plastic block. Furthermore, they tell me that each plastic block requires 96 cubic inches of plastic. Notice what I just wrote up there. 96 cubic inches. They did not tell me that this is volume, but it is volume. 96 cubic inches. There's a glare directly on the X. Move that over a little bit so the glare doesn't get it. Yeah, there's the x. There we go. Good. When you are dealing with a unit that is cubed, inches cubed, meters cubed, things like that, you are dealing with volume. You dealt with various things in volume and geometry. I'm assuming at various points, like in the beginning of geometry, you may have learned some of the basic formulas for like the area of a triangle, the area of a trapezoid, and then you tried to memorize those. Were you guys given formula sheets in geometry? Or did you have to memorize all that? They were on the board? Cool. I haven't taken geometry in a long time. But anyway. Then you also learned various formulas for volume. Anyone know the volume of a sphere off the top of their head? No, it's difficult. It's like 4 pi r squared or something like that. Some weird junk I don't even know. But regardless, I may have that formula wrong, mind you, because I haven't taught geometry in like a long time. But my point being, you have all these different formulas for memorizing areas and volumes. This is a volume. How does one find the volume of a rectangular prism? What do you do? Let's go back to a rectangle. Just shout it out real quick. How do you find now listen, the area of a rectangle? Area of a rectangle. Length times width. That's something like, length times width. Nailed it. Okay. If the area of a rectangle is length times width, now I want to find the volume of a rectangular prism. How does one go about that? Length times width times height. Yeah. It's like a cube, rectangular prism, same concept, length times width times height. That's pretty much what you guys did for like a lot of like prism type shapes. For example, if I had like a triangular prism or some junk like that, you would find the area of the triangular side, and then multiply it by like the length or the height of the object, you know? Or if you had a cylinder, it's like you find the area of the circle and then multiply it by the height. Same concept here. You find the area of, let's say, the bottom rectangle and then multiply it by the height. That would give you the volume of that thing. Well, that's what we're going to do here. In order to get this done correctly, I got to multiply length times width times height, and that should give me the volume of that particular plastic block. Now, how in the world does this relate to anything that we have been doing over the course of the past several weeks? It has everything to do with what we've been doing. Oh no, the bottom of this thing just broke. There we go, I fixed it. Better. It has everything to do with what we've been doing in the past several weeks. Because even though the problem is not asking us to do the following, we need to, based on what is in front of us, we need to figure out what x is. We need to figure out what is the value of x in order to continue with what this problem actually wants. Notice I haven't even fully read the problem yet. I just labeled this plastic block out and figured out an equation. Let's see what we can do with it. Let's multiply this junk out. Put that there. So if I'm going to multiply this junk out, I'm going to distribute this x, because I got to multiply all three of those things together. I'm going to get an x squared minus 2x, and I got to multiply it by x plus 8. Now, you could FOIL if you wanted to. You could totally FOIL, or you have a binomial and a binomial. For me, it makes more visual sense to multiply these two things together like this. For me, it kind of helps to do it that way. But again, you could totally do FOIL if you absolutely wanted to. Perfectly reasonable to do such a thing. I'm just checking the chat right now. I have the... Here we go. I just needed to open up the chat on my phone here. But I'm going to multiply this chunk out. Be careful when you multiply this out. Make sure that the terms are what they should be as we're moving forward to kind of get this thing done. I'm going to zoom in on this portion right here. There we go. I'm going to combine like terms, and I'm going to get an x cubed plus 6x squared minus 16x, and the whole thing equals 96. I'm going to recap what we just did, but just for the sake of argument, the reason why that worked out is because a negative 2x squared and a positive 8x squared, when you add them together, make a positive 6x squared. The other terms just came down where they were supposed to go. So now, let me recap exactly what in the heck just happened. First, we were faced with the following problem. I'm going to put this back up here so we can see it. Zooming in, zooming in, zooming in, zooming in. Here we go. A tool shop is hired to make a metal mold in which plastic is injected to make a solid block. See the diagram. Now, all the next information is all about the plastic block. The finished plastic block should have a length that is 8 inches longer than the height. It should also have a width that is 2 inches shorter than the height. We labeled all of that stuff. Drawing our three-dimensional rectangular prism. Each block requires 96 cubic inches of plastic. That is our volume. Now, let's just take a look at the question real quick. If the sides of the mold are to be a ½ inch thick, how much metal is required to make the mold? What does that have to do with anything? Well, that question, we'll come back to that question. We can do other stuff in the meantime. But I was able to draw, I'll zoom back out. I was able to draw that block according to the dimensions that they described in the problem. Length times width times height should give me the volume of that rectangular prism. We were able to begin multiplying out that equation, setting it equal to 96, and now we have this. Now this is where we've been for the past many weeks. A polynomial. I got to solve this thing. What must I do? How do I even begin this process? I have a polynomial that I have to solve. Any suggestions? Ooh. X cubed plus, it's clearly a cubic. I have a third degree polynomial. What's one of the first things that we always do with these problems? I can hear the crickets. I can hear them from the other side of the world. What did he say? Oh, in the chat, he says subtract the 96. I agree with you. He says subtract the 96. Subtract the 96. I agree wholeheartedly. Let me do that. Because if you are going to begin solving a problem like this, just like we have done from the beginning of the school year, you need to have one side of that equation equal to 0. That is the only way that we are going to be able to begin this process. Joe, I see you in the chat. Do you know what we got to do next? Oh, yeah. What? No. What do we do next? How do we begin to solve this thing? What have we been doing every single time for the past several weeks? He's not answering in the chat. He says the box thingy. What's the box thingy?
I think he means thing you already did.
Well, that's to multiply them out.
No, I'm saying I think he means the thing you already did. The box.
This thing?
Yeah.
Maybe. Oh, he says no. He says the other one. He says synthetic division. He said no multiple times. Oh, no. She said synthetic division. Yes, sorry. Look, here, I'll show you. I'm literally, they're in the chat right there. Can you see them? And she did say synthetic division right there. And then he's like, no, the other one, no, yes. So literally, I love having the chat right here. It's so nice. But she did say synthetic division. Yes, it's exactly what she said. We have to do some synthetic division. We absolutely do. If we're going to solve this thing, we got to knock out some synthetic division. So 1, 6, negative 16, negative 96. Those are the numbers that I put on the inside. Absolutely, yes. What number do I put on the outside? I don't think we have a number. I don't know what to put on the outside. If I'm going to do some synthetic division, which I absolutely agree with what they're saying in the chat, what number do I put on the outside here? Oh, no. Joe says 3. Joe, where'd you get 3 from? Where'd you get 3 from? I don't know. Is it a 3? I actually don't know if it's a 3 or not. How do we know for sure? Now he says 3 or 2. Now he's saying 8. He's just saying numbers. What do we do? How do I know what is possibly a solution to this equation? Say again? Let's look at the graph. Let's look at the graph. He's saying all these numbers. Joe, hold on a second. We got to look at the graph. We have to look at the graph in order to determine what the heck is going on with this thing. We have to look at the graph in order to determine where it has crossed the x-axis in order to begin this process. The question usually is, what number do I put here? Let's look at the graph. If we look at the graph of the problem, it'll give us a much better idea as to how to go about this. So let's do that. Let's see here. Desmos. Of course, you all have graphing calculators on your Chromebooks, but we'll just look at this thing together right here. Cubed plus 6x squared, that's a 32, squared minus 16x minus 96. Holy crap. Okay, now keep in mind, this problem didn't ask you to graph. This problem doesn't want you to graph it. But using the graph, looking at the graph is going to be incredibly helpful for determining where to start it. Now, I typed in the equation. According to the graph, I am very interested in where it crosses the x-axis. I am very interested in where it crosses the x-axis. Absolutely, yes, I am. So, all right, cool. That looks like a 4. That looks like a negative 4. That looks like a negative 6. All right, let's prove it. 4, negative 4, negative 6. Let's go back here. Let's try it. Let's put a 4 in. Where'd I get it? I got it from the graph. Look at the graph of the equation. Let's try some synthetic division. 1 plus nothing is 1. Multiply, add, multiply. Oh, these numbers are getting big. Add, what was that, 24. Multiply 4 times 24. Oh, that's 96. It worked. That's awesome. I can't believe, I mean, I knew it was going to work, but those numbers just worked out quite nicely. All right. Let's keep going, though. I got to prove this sucker. I got to prove this sucker. I got to prove the rest of these things. The resulting equation is actually a quadratic. That's actually a 1x squared plus 10x plus 24. But I'm going to keep going. I'm going to keep proving the zeros that we saw. -4, let's throw the -4 in there. Let's keep dividing this thing down. It worked. Excellent. Can't believe that worked. That's pretty solid. Well, we did have one more zero to try. We did have one more zero to try here. And that other zero gave us something like, oh, it was -6. That's right. I'm just proving it right here, going down with the synthetic division. Yep. That one worked as well. So what have we proven? We have proved 4, -4, and -6 are zeros of the function. That is what we have proven. That is not the answer to the problem, but that is exactly what we have proven. But it tells us a bit more right now. Let me recap what we've done. Let me recap what we've just done to kind of see where this is going to take us. We had that problem. They gave us the information on the plastic block. We drew out the plastic block and labeled the sides accordingly, according to the problem. That is where... There we go. They gave us the dimensions of the plastic block. That is where we got this information right here. We multiplied out that length times width times height. We multiplied it out. And it gave us the following equation. It gave us that x cubed plus 6x squared thingy. In order to move forward with the problem, you have to get one side equal to 0. We got one side equal to 0. We wanted to do synthetic division in order to solve it. So we looked at the graph. We looked at the graph and we found 3 possible zeros, which we went through the process of using synthetic division to prove that they are zeros of the function. I'm going to tell you something, though. These 3 numbers right here, we actually only need one of them. Which one do we need? Why? I need a little more context. Yes, the 4 is the only positive number, but I need a little more context. Why is it important that we use the positive number? What does it represent? What does it represent in the context of the problem? Sorry. I agree with you. It is the 4. And it is important that it is positive. What is x, though? The height. That's why it has to be positive. X represents the height of our original shape that we drew right here. That is why it has to be positive. It has to be that positive value. It absolutely has to be. Yes, sorry, I'm looking at the chat right now. Couldn't we just... Okay, let me go back a little bit. She asked the question in the chat. Yeah, right here. She asked the question in the chat. Once we got down to this quadratic right here, the x squared plus 10x plus 24, she asks, couldn't we just factor it? Answer, yes. Yes, you could have. You absolutely could have. When you get it down to a quadratic, you have options. Once you get it down to a quadratic, you could either, 1, continue with synthetic division, which is what we did, 2, factor it, which is what she asked, or 3, quadratic formula, which is another option. I opted to go with more synthetic. She may have opted to go with factoring. Either way would have been absolutely 100% correct. So x has to equal 4. So the dimensions of plastic block are ... Here's my little plastic block right here. And I got the dimensions. Well, if x is 4, then the height is 4. Then the length is 12. And the width is 2. Those are the dimensions of our plastic block. Anybody know what 2 times 4 times 12 is off the top of their heads? You don't have to guess. It's 96. It's 96, which is the volume that we wanted. It's the volume that we wanted. Now, it doesn't answer the question. We're still not at the answer to the question. But let's walk through it like this. I know, but this is exactly why I told you at the beginning, I wanted to do a deep dive on a word problem. This is what I wanted. Yes! It's amazing.
I mean, yeah, maybe right now, but if you test, you're putting time.
No, I know. But if you notice, I am purposefully taking my time with this. Yeah. I'm doing that to show you the individual steps that are involved with getting this thing done. It's amazing. I once had a problem in college. It was an extra credit problem, so I didn't have to do it. I spent all weekend working on it. All weekend, 8 pages worth of work working on it. Monday morning, I took my 8 pages of work on this one problem. I walked into my professor's office and I tossed the papers at him. I said, there you go. They were stapled, so they stayed together. And he looks it over. He's like, oh, yeah. I'm like, yeah. He's just like, it's correct. I'm like, I know it's correct. And he's just like, okay, well, look at this. And he proceeds to show me how to do the problem in 30 seconds. And I'm like, not a problem. And he's like, you sure? I'm like, yeah, not a problem. Because nobody showed me how to do it. I figured out how to do it. It took me all weekend, but I figured it out. Not Google, not a professor, not someone else, but me. That's why I love problems like this. So here's what we have. We have the plastic block. I want you to draw this. We have the plastic block with the following dimensions and volume. We have the dimensions of 12, 4, and 2, which give us a volume of 96 cubic inches. Then we have the metal mold. The metal mold surrounds the area, it surrounds the volume of the plastic block. Now, let me go back to the problem. Let me go back to the problem real quick. Check this junk out. It's amazing. Look at this. I'll come back to that paper in a moment. If you didn't get a chance to draw it, I'm going to come right back to that paper. If the sides of the metal mold are to be a 1/2 inch thick, how much metal is required to make the mold? Now, what that really means is this. The metal mold is what is surrounding the plastic block. The metal mold is on the outside of the plastic block. You have the metal mold, which is hollow on the inside, 1/2 inch thick walls. By the way, how many sides are there to this rectangular prism? How many sides are there? How many sides are there, let's say, to a cube? There's 6 sides. Yeah. Left and right, top and bottom, front and back. 6 sides. We have to think about this logically for a moment. The metal mold is on the outside, the plastic is on the inside. Let me go back to this picture. Let's go back to this picture. Here's the thing now. The metal mold is on the right. The plastic is on the left. If the walls are a 1/2 inch thick, what is the height of the metal mold? If the top and bottom are a 1/2 inch thick, what is the height of the metal mold? Ooh. Ooh. I've kind of spelled it all out for you guys. You just got to take that extra step. The metal mold is surrounding the plastic block. Metal mold, you inject the plastic into it. It's how it makes that plastic block. The walls of that metal hollow mold are 1/2 inch thick. If the height, I'm looking at the height, the top is a 1/2 inch, the bottom is a 1/2 inch, what is the height of this metal mold? What's the height of the plastic block? 4. The height of the plastic block is 4. Now remember, that's inside this metal mold. 1/2 inch thick, 1/2 inch thick, it's 5. What's the length of the metal mold? Say again? 13. What's the width of the metal mold? 3. 1/2 inch thick on each side. The metal mold should have the following dimensions. If you multiply all those together, the volume is 195. How much metal is needed to make the mold? What volume of cubic inches of metal do we need to make this mold? You got to take this extra step. Some people are thinking it, they don't want to say it. I'll give you a hint. It's not 195. It's not 195. What's on the inside of this metal mold? It's the plastic block. They want to know how much metal is needed. So you have to remove the plastic block. How much metal is there? What do I have to do with these two numbers? What do I have to do with 195 and 96? Subtract them. You got to subtract them. Oh, he said it in the chat too. He said it in the chat like a 1/2 second. If you subtract them, then you get the following answer. There are 99 cubic inches. That is the amount of metal to make the mold. People look at word problems and they immediately say, this is exactly why I hate word problems. This problem is exactly why a lot of people hate word problems. I'm going to tell you, this problem is exactly why I love word problems. This type of problem is not just easy enough to solve it in 30 seconds. This is the type of problem that you have to dig deep. You have to sift through the garbage. You have to persevere in order to get to an answer like this. Yes, it takes a little bit of insight. It takes a little bit of strategy. But this is the exact type of problem that makes you think beyond what you are capable of thinking. And you know what most high school students do when they come up to this problem? Do you know what most high school students do when they face a problem like this? They either guess or they leave it blank. I'm like, come on. This is everything that you can do. It's just taking several different aspects of what we've been learning over the course of many years and putting it all together in a puzzle for you to figure out. I love problems like this. They're amazing. There's one more thing I want to do today. As I said at the beginning of class, we were going to spend a long time with a few problems. It's the last thing I want to do today. Write down this equation. Like I said, long time with a few problems. I have the following. F of x equals negative x to the fifth plus x to the third minus x to the second plus 1. Tell me something about this equation that I need to recognize right off the bat. And when I ask that question, keep in mind there's like at least 3 or 4 things that you can tell me. What's one thing that I need to know about this equation just by looking at it? What's one thing that could potentially help me towards understanding whatever it is that I'm about to ask you to do? Because I haven't even asked you what to do with it yet. What's the degree? What's the degree of the polynomial? I'm hearing those crickets again. What's the largest exponent? Yeah, it's a 5th degree polynomial. What's the leading coefficient? What coefficient? Oh, he says 5 in the chat. What's the... Oh, no, it wasn't him. Sorry. I wasn't looking at the name. What's the leading coefficient? What number is in front of the variable with the largest exponent? What number is right there? It's -1. That's going to play a role, having it be a -1. Ooh. Finally, are there any terms that are missing? That's going to play a role later as well. X to the 4th and x to the 1st are missing. That's going to play a role in a little bit. Let's take a look at the graph. I want to take a look at the graph of this thing. So I'm going to throw this junk. Into Desmos. And let's see what we can get here. Negative x to the 5th plus x to the 3rd minus x to the 2nd plus 1. There are several things that I need you to recognize right now. There are several things that I need you to recognize by looking at this graph. Now, mind you, we're not going to complete this entire graph, but I really need you to see it. First of all, there are only 2 visible zeros that I can identify. There are only 2 visible zeros that I can identify, and they look like +1 and they look like -1, and they are. What is happening right here? What is happening at this -1? It's a term that we have covered, a phrase that is going on with this graph, something that we need to recognize, something that is deep down in our notes. What is the graph doing at this 0? Ooh. What does it appear to be doing? It's like, oh. What does the graph literally do right here? No one wants to say it because they're too scared. Or they just don't want to do it because they're not paying attention. They just don't want to do it because they're playing on the phones or watching YouTube videos when they really should be focusing on this because you have a major this week. And I've seen the grades on Edulastic. They're not that solid. Ladies and gentlemen, there's a turning point there. There is a turning point at this particular value. And something that is written into our notes, something that we have talked about, is the fact that if a turning point occurs, at an x-intercept, then you have what is known as a repeated zero. You have a repeated zero. Now, how many times does it repeat? I don't know. But we can determine that. We can determine that by going over here. Shaboom. First of all, let's start with this. -1, 0, 1, -1, 0, 1. Those numbers came directly from the equation. -1 is the leading coefficient. She told me before that x to the 4th was missing. Then it was 1x cubed, -1x squared. Then the x was missing. Then a +1. Let's try this. Let's try it with a -1 there. Because that was the I can't even say it. The visible zero on the graph, or one of them. -1, +1, 1, -1, 0, multiply, add, multiply, add, multiply, add. It worked. Let's try the +1. If we were to try the +1, I get the following. Now, the thing that I want to point out is this. When we divided out that first 0, we went from a 5th degree to a 4th degree. When we divided out that second 0, we went down to a 3rd degree. Remember, remainder, constant, x, x squared, x cubed. I gave you that note about repeated zeros. And since there is a repeated 0 at -1, I don't know how many times it repeats, but it does. It does. At this point, ladies and gentlemen, I'm just going to verbally tell you what's going to happen next because I'm out of time. But at this point, you have a quadratic in which you would solve this quadratic by using the quad formula, and you would actually end up with complex solutions. We're going to have to finish this up on Thursday. But as I said, I am assigning you a major assessment that will be coming out at some point tomorrow. So be ready for that. I'm going to sign off. Goodbye, those in the chat. Thank you for participating.